This is an atom and this is an ion. They are two different things which confuses students a lot. This one is neutral and has not undergone any chemical reaction. This is an ion, meaning that it has either gained or received electron. And for you to see whether it has gained or received electron is as a result of this sign that you see on top of it. Now, whenever you see the 2 plus in ions simply means that it has loosed or given out. That is a clue about it. Then when you see minus mean that it has received. Good. So over here, let me write the electrons down so that you get it easily. Okay. So over here, looking at it very well, if I'm seeing negative 2, it means that it has what? Received what? 2 electrons. If you see positive, it means it has lost 2 electrons. I getting it? To be stable. The reason why they have given this out is to make them stable, meaning that their last shell to what? Complete. Now let's see the difference of what I was trying to talk about so that we don't get confused. Suppose you have calcium, okay, which has an electronic configuration of 2882. I getting it? This one is the atom of calcium. When I draw the electronic configuration this way, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let me draw the last one, which is 19, 20. Over here, protons over here is what? 20. We know already. And we know protons are positively charged. So in other words, it's plus 20. Electrons, 2 are 20 over here, which is what? Minus 20, because electrons are negatively charged in an atom. Good. Now let's see something over here. This one, as I said, this is called atom because it has not undergone chemical reaction. It's a neutral atom. Now let's see for the ion and see what happens over here and why we have that charge. So over here, calcium, okay, need to be stable. And since it needs to be stable, it has to have its last shell being 8. So it will give out these 2 electrons out so that it will have its last shell here to be 8 to be stable. In doing so, when it gives these 2 out, the next electronic configuration over here for it will become this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I didn't write these 2 because it has given these 2 out. It has given out to be stable. Good. Now, we know this is for what? Calcium, right? Now, before that, you know calcium in its normal state, the protons is 20. Protons never undergone the chemical reaction over is 220. Now, the electrons has received other 2, has given out 2. So the electrons over here, 2 has been given out over here. So the electrons are not going to be the same. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So now the electrons are now becoming what? 18, which we know they are negatively charged. Now let's do the mathematics and see something. Positive 20 minus 20 here will give you what? 0. That is why we normally say an atom is electrically neutral. And you know the neutral, we use 0 to represent it. You get it? Good. Now let's see here. Plus 20 minus 18. We are going to get what? Positive 2. That is why calcium is written as what? 2 plus. To show you that it received 2 other electrons. Because when you work it out, you see mathematically it will give you what? Positive 2. That is why calcium or element that lose always are positive and those that gain are always negative. So always take note of the difference between atoms and ions. When it's having the charge, they are ions. When it's standing straight like this, they are atoms. Okay.